Hey, good morning. How are you doing? I hope you're doing well. We are going to, this will be a very short video. I'm going to call it like organization of the periodic table. We'll look at some properties, some very basic information. Okay, so I'm going to go ahead and share my screen here. Share. Let me start share. Oh, good. That worked well this time. Beautiful. Okay. So you see I've got my periodic table pulled up, and I'm actually going to scroll up for a minute. All right. And let's look at a couple things that you are and may not be aware of. Okay. So first of all, hopefully you realize I do not want pink, I want black, that the periodic table is organized by increasing atomic number. Okay, they had attempted to organize it by increasing atomic mass, and there were some inconsistencies. So they redid it by increasing atomic number, and a lot of things fell into place. They were able to predict properties of elements that were not even discovered yet. And then when they discovered them, they realized, well, that's exactly what we predicted based on the location an element resides in the periodic table. The periodic table is actually a lot more than it appears to be. It is a graphic organizer, okay? And we are going to start looking at some of the properties that we can predict about elements based on their location on the periodic table, okay? Oops, I have a mistake there. Okay. Karmic number, it's a huge graphic organizer. Okay. So I'm going to erase that so that I can continue to focus on a periodic table. Now, if I was you, I would kind of go like this. I would go like this, right? Give yourself a rough draft of the periodic table. And you'll see there's like a stair step right here. Here is that stair step I'm referring to. Okay, so hopefully you can see that right there. I think you can. Let me give a different color. One more stair step here. I'll do it in black, right? That's my stair step there. Okay, now I'm going to go back to this one. What we have here is we've got our S block, we've got our P block, we've got our D block. I'm not really worried about the F block. Okay, we're not going to be dealing with those very rare metals. These are our group one. Remember, groups are up and down. That's vertical. Groups are vertical columns. Okay, and periods are horizontal rows. Okay, all right, cool. And I'm going to go back. I'm going to draw this again. And I've detailed this in a video, but we can number these with our A's or our B's. This is group 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. All right, I tend to number my groups as such. You can also number them as 1A, B, 2B, 3B through 12B, right? And then this becomes 13B, 14B, 15B, 16B, 17B, and 18B. All right, but notice, it's either 3 or 13, 4 or 14, 5 or 15, so on. All right, and you should already be aware from electron configurations that there are a total of 7 periods. All right. Okay. Now, group 1A, the first group on the left side is called the alkali metals. All right. These are the most reactive metals. All right. Group 2A, losing my mind, are called the alkaline earth metals. All right. They're reactive, but they're not as reactive as the alkali metals. Okay. In the D block here, and then it also ranges over here, are your transition metals. All right. Remember that the D block, the transition metals, are not representative elements. Remember, just the S block and the P block are your representative elements, where certain trends are represented by them that are not represented by the transition metal. Trans means change, and some of the properties of these transition metals change. So there's your D block, and the some of the P block metals. Right, and what we're going to learn is our transition metals have something called multiple charge cations, and I will we'll talk about that later. Okay, but most of those transition metals have something called multiple charge cations, where they, remember, a cation is a positive ion and it's formed by losing electrons. So we'll see that those transition metals, sometimes they lose 1, sometimes they lose 2, sometimes they lose 3, sometimes they lose 4. So that's what I mean by multiple charge. They have a +1, +2, +3, +4. We have different charges. Okay, so now what we realize is, looking at our periodic table, let me get a different color since yellow has already been used. Let's get that right there. We realize that all of these here are metals, right? Those are my metals. The first group are the alkali metals, the second line are the alkaline earth metals, and then the D block are the transition metals. Please realize that hydrogen is an element that lives right here. And hydrogen is not a metal. All right? Even though he lives over there with the metals, he is not a metal. He's over there for other reasons. All right? He's got 1 valence electron like everybody else in that group. He's not a metal. Okay? And he's not a he either. Now, over here, let me go back to my periodic table. So what you would see, guys, is this here. Oops, I don't want that big old thing. Look at my time, I'm about to have class. Okay, this here are my alkali. Group 1, alkali is 1 word. These are my alkaline earth, okay, metals. And then these here are my D block transition metals. These are metals, and all of these are metals. So what you should notice, right, oops, not hydrogen, is most of these elements on the periodic table, most of them are metallic in nature, right? Look, almost all of them have metallic characteristics. I know that's messy, but all of these from this baby blue over have metallic properties. So what are those properties of metals? Well, they have something called a sea of electrons. I'm not going to get into that right now. We'll talk about it more when we talk about bonding. They are malleable. They can bend and be shaped. Ductile, similar word, they can bend and be shaped. They're excellent conductors of electricity. and heat, right? And that has to do, all three of these have to do with the fact that they have something called a sea of electrons. The electrons are free to roam. We'll talk about that later. Metals lose valence electrons when bonding, right? We're going to get into bonding soon. Thus, metals form cations. That's ugly word. Cations. Remember, a cation is a positively charged ion. All right. So those are your basic properties of metals. I'll finish this up shortly. Okay. Now, let me clean up my periodic table because I have scribbled all over it. It is a hot mess. Okay. Now, over here, okay, to the right of the stair step, we have our nonmetals. All right. Nonmetals to the right of the stair step. Okay. There's not very many of them, right? They're not very prevalent, right? They're just these guys right here. Like I said, those guys right there. Let me go back to metals. Metals are solids at room temp, right? With the exception, our paper's getting messy. Metals are solids at room temp, except mercury. Mercury is that liquid metal, right? Quicksilver, what they call it. Mercury is a metal that is liquid. It's so pretty, but it's dangerous. All right, you have nonmetals. These are all solids, liquids, and gases at room temp, all right? And we will get more into why and what determines that. Nonmetals, let's see, group 7A are your halogens, all right? That would be this group right here. Let me clean up my periodic table again. This group right here, I don't want that. We're fluorine, chlorine, bromine, iodine. Those are my halogens, right? You need to know that. They're also called halides. Those halogens are the most reactive nonmetals. Okay. Group 8A are your noble gases. Right? These are inert. Actually, I'm going to rewrite that. I'm going to write chemically inert. Which means they are non-reactive. Okay? Why later? And metals are poor, nonmetals. Nonmetals are poor conductors of electricity and heat. They are brittle. They break easily, if in fact they're solids. Some of them are, most of them, or a lot of them are liquids and gases. Let's see. I'll get to that later. Br2 equals liquid. I2 equals solid. Carbon, solid. Phosphorus, solid. That's basic. Okay. And then lastly, we're going to look at the elements that are on the stair step. That's our boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Polonium is not stable. All right, so on the stair step, those stair step elements are called metalloids or semi-metals. And that makes sense because they are in between the metals and the non-metals. So they're semi-metals, right? So they have characteristics of both. And what they are excellent. No, they're not excellent. Oops. They are, semiconductors. And several of them are used in computer chips. And they're better than metals for that purpose. And that's about all you need to know. And I'm going to end it there. Please take your notes, ask me whatever questions you have. It is important that you, let's go back to nonmetals. We said that metals form cations. Metals lose valence electrons when bonding. I'm going to say this a little bit differently. Nonmetals gain electrons when forming ions. No, I didn't. Notice I didn't say when bonding. All right, that makes them negatively charged, and we call those anions. So metals form positive cations and nonmetals form negative anions. That's going to be important. All right. It's also important. So Miss Murphy kind of thinks those are two of the very important points here. Nonmetals gain electrons, forming anions, and metals lose electrons, forming cations. All right. It is important that you know your alkali metals are the first group, your alkaline earth metals are the second group. Your halogens are the next to the last group, and your noble gases are the last group. All right, so you need to know the first two and the last two groups. Please bring any questions you have to me, okay? Thanks. That's gonna be it. I told you, simple, simple. End.